Hello and welcome to today's webinar. I will now turn the event over to Lori Pollock. Lori, you have the floor.
Hello, welcome to the CRA-W Undergrad Town Hall. I'm Lori Pollock from University of Delaware, and today we have Alexandra Meliou from University of Massachusetts Amherst. And she's going to be talking to us about big, messy data, which sounds quite interesting to me. So before she gets started, we have a couple logistics. Could you move the slide, Alexandra? So the first thing is there's two different ways you can interact with this webinar. One is through asking questions at any time you want during the talk and between the talks. So there will be two different talks, one where she's going to talk about research and one will be a mentoring topic. At any point in time, you can type in a question, and I will relay the question to Alexandra while she's talking and right after the research segment. The other way you'll be interacting, on the next slide is an example of polling. So there are several polls throughout. We're trying to gather some information about who's on the call. And so at certain points, she'll be pausing to take a poll. So we want you to go ahead and answer the question. You have to be fairly quick before we close the poll so that we can move on through the talk. So please just click on the polling, which will be over on the right side, not exactly on the slides. Okay, so today on the next slide, we are describing a little bit about Alexandra. She's an assistant professor at University of Massachusetts Amherst. She's done a postdoc at University of Washington and earned her PhD at University of California, Berkeley. She's gotten a number of awards, both for research and teaching, which is unusual for faculty. Usually they get some of research or teaching, but she's obviously good at both. So, and she's also gotten the research awards from two different SIG communities, which is quite interesting, SIGMOD and SIGSOFT. So today I'm going to leave it over to Alexandra and let her get started. Welcome.
Thank you so much, Lori. As Lori pointed out, I will be talking about data today, and specifically, I will focus about the way data is used through systems that we may be using every day. So we're starting with a poll, and the poll is asking you how frequently you use any of the technologies that we list here or similar. Things like social networks, Facebook, Twitter, Instagram, things like rideshare services, movie sites like Netflix and Hulu, or YouTube, various news feeds, online vendors. So we're asking you to give us an estimate of whether you use these things very frequently, something like every day or most days, infrequently, rarely, or even almost never, to start getting a sense of how pertinent all these things are in all of our lives. So we're going to see the poll has ended, and we're going to see the results very soon before we continue. So it looks like 100% of you use a lot of these technologies every day, which is what we mostly expected. So let me see, because my slides are not progressing. Okay, so this is very common. You're not unusual. Actually, technology permeates a lot of aspects of our lives now, not just with the technology that I listed in the poll, but in a lot of other, things, from the mundane to the very, very important. For example, algorithms now decide whether we get loans and various financial decisions. There's even robots and other related algorithms and systems that make medical decisions and even assist in surgery. And even within the criminal justice system, we have software which determines whether an assailant, someone who's under criminal investigation, is likely to reoffend. And in many states, judges are supposed to use this type of software, see the results before they decide on sentencing. So clearly, this type of software is very important, and it's in many aspects of our lives. from the search results that you get to smart driving cars. And what drives all those types of software is data. A lot of this software relies on data. So data drives what products you see, what recommendations you get from online vendors, what recommendations you get for various financial decisions, the ordering of the search results that you see when you look for something on search engines, and even the information that you see, that you consume, the news that you read on social networks and various news sites. So data really impacts our daily activities and eventually even transforms and shapes a lot of aspects of our lives, including perhaps our opinions. So data is clearly very important. But what happens if this data has problems? For example, if data is dirty, that means it has errors. Or if data is biased. These are the types of problems that I will focus on today's talk. And first we will start with the first part. What if data is dirty? That means has errors. Errors in the data affect a lot of things, can have grave impact in the way that we use various types of software in our lives. Data errors have actually wiped away people's life insurance. Data errors have resulted in $1 million accounting errors that threw off budgeting in school districts and a lot of other places. And even data errors have resulted in medication errors and adverse medical outcomes and even death in some cases. So clearly, this is something very, very critical. This is why data quality is a major focus for many companies that deal with data, because they recognize the risks and costs that are associated with it. That's why, in recent estimates, bad data, bad quality data ends up costing the U.S. economy in the trillions per year. So this is clearly a significant problem. When we're talking about data quality, though, it's not a problem that it's new. You can see that research in data management has focused on issues of data quality for many years, decades even. So why are we still talking about this problem? Why is this problem not solved? Well, the issue is that data has fundamentally changed, and with it, the issues of data quality have changed. So now data comes from a very large variety of sources, including medical data, geography, web data, social network data, DNA sequencing, various scientific data. The variety in format, in sources, and the immense volumes of data have all increased the challenges that we face with respect to dealing with data quality. This is why this is still a pertinent and really critical issue. So we have been working in my community, the data management community, in data cleaning for a long time. The problem is data is dirty, meaning it has errors, and the focus has been in figuring out where the errors are and fixing them. So data cleaning techniques involve a variety of aspects. They can be automated, semi-automated. They may include some manual components, labeling, crowdsourcing. But I would like to take a step back and ask the question, why is data dirty in the first place? This is the problem that I would like to focus on. And in order to do that, I would like to look at this problem from this perspective of a particular application, which is knowledge bases, and I will describe what that is. So when you search on the web for some popular information, like prominent politicians, musicians, actors, etc., you often get a nicely formatted info box like the one you see on the slides that has structured information. So here you see some information for former President Barack Obama, including date of birth, when was his presidential term, parents, and so on and so forth. This structured information is actually retrieved from unstructured web data offline, and then that structured information is used to power applications like web search. So here's how this structured information is often produced. So you start on the bottom here on the slide with unstructured data in a variety of web sources. This can be in the form of text, tabular data, various annotations, and a lot of other formats. Now, all of this data gets processed through vast knowledge extraction pipelines that are very complex. And the extractions that they produce, then they get together, they are brought together into what is known as a probabilistic knowledge base. So a knowledge base contains small structured bits. For example, from a piece of text, a Wikipedia article, you may parse a little bit of information that says that Barack Obama was born on this date, and then you create a knowledge triple that has the entity Barack Obama, a predicate, born on, and then a particular date, the object. So this is like a structured information that gets put in this probabilistic knowledge base. Now, examples of these probabilistic knowledge bases are in many places. One of them is in Google, a large company that I believe most of you know of. One of those knowledge bases was called at Google Knowledge Vault. It contains 3 billion extracted triples in that order or more. So it's immense. It's very, very big. Now, the catch is that a very large percentage of those extracted facts were labeled with low confidence by the extraction system, which for practical purposes, it means they're incorrect. This is clearly a huge problem. There's a lot of work that goes into this knowledge extraction process, and getting such a vast percentage of it to be thrown out is something that no one really wants. So why is this happening? Well, traditional data cleaning would just look at where the problem is, where are the errors in the data, find those errors, and then just purge them, get rid of them, so that you get a perfect data set, in this case, a perfect knowledge base. The problem with this is that you are only left with a very small percentage of the work that you actually did, and what I want to argue is that this doesn't quite fix the core of the problem. So the problem is that a lot of these errors happened for reasons that are inherent to the system that generated them. So the errors did not randomly appear in the knowledge base we produced. They're systemic. They're part of the system that produced them. There's things like, for example, faulty information from the web sources. There's a lot of spam on the web. Or there are some bad extraction rules possibly in the knowledge extraction process. Something in the code is wrong. Or possibly you have some rules that just are not applied correctly. For instance, let's say that you're trying to extract date information, and you're using a US-style date pattern that puts the month first and then the day on European web sources. In Europe, we usually put the day first and then the month. So if you do that, if you apply a rule to an incorrect source, you end up getting incorrect data. A lot of the dates that you would produce this way would be wrong. So then if you don't fix these errors, you will just keep producing bad data. So the errors, I argue, need to be fixed in the system, not just in the data. Now, there are many challenges in dealing with this. So first of all, the scale is simply massive. As I talked to you about knowledge bases as an example, we have billions of triples to deal with. But in any data set that you look at today, you can, I'm sure that you've heard of, big data and big data volumes. The scale becomes a big, big problem because any sampling that we try to do loses statistical strength and misses a lot of mistakes. So this is a challenge that we have to deal with when we're working on these problems. Now, in the particular problem that I described to you, we also have to deal with the system complexity. Knowledge extraction is a very complex process that involves a lot of components. It is very hard to debug directly and hard to reverse engineer. And finally, we also deal in this particular application with very high error rates. Basically, the noise to signal ratio is just extremely high. So all these are challenges that we have to deal with. We did produce a solution for this problem. It's a system called Data Xray, which is parallelizable in the MapReduce framework and works with simple metadata. I will not go into the details here of exactly how the system works, but I will give you an example of what the system does. So the system is agnostic of the process that generated the data in some way. So it doesn't try to directly debug the system, but it tries to identify some high-level information that will help pinpoint the problem. For example, I'm giving you here a type of error that Data Xray discovered in Google's Knowledge Vault knowledge base. So it identified the summary that I have on the slides in red, that the source bsalter.com and the predicate type date of birth and object type this particular value of date. Now, what it means by that is that triples that were extracted by this particular web source, this particular website, all demonstrate the same date of birth, this particular default value. So the context of what happened here is that this was a copy-paste error. Someone copied HTML segments, and you know some segments of the text that constructs a web page does not always get displayed on the page itself. So potentially this error was just someone just didn't care to correctly fill in the copy-pasted information and update it for all of the athletes that it was extracting information from. And what ended up happening is that these copy-pasted segments ended up resulting in all the athlete information having the same date of birth, which was a mistake. So while Data Xray doesn't identify where the error is in the code, it gives this type of summaries that help sort of stakeholders figure out exactly where the problem is, more or less. Okay, so I would like now to talk a little bit about the second topic. What if data is biased? And what do I mean by that? Here we have a second poll. Before I describe to you specifically what the bias is, I would like you to think a little bit about various applications, various technologies that you may use, and let us know whether you have observed any type of what you consider bias or misbehavior of these systems, whether you've seen it firsthand, whether you've heard that such technologies that you use may have biases, even if you haven't seen it personally, you haven't observed it personally. And third, whether this is a problem that you hasn't crossed your mind, you haven't heard anything about it, you haven't seen it, and you know you don't believe that technologies that you use may demonstrate such a behavior. There's no right or wrong answers here, so don't worry, don't overthink it. It's just about giving us a very rough sense of whether this might be a problem that crossed your path or not. So you put in your answers, and we're going to see in a little bit. Again, you know, there's no right or wrong here, but and you know, since I am going to talk about this, obviously, you know, I'm going to talk about biases, so I will demonstrate something to you, but I'm curious to know whether you have seen it or not. So it looks like, so no one picked the last option. Some of you have seen it said firsthand, more of you than I expected, actually, and 40% have heard something about it but haven't seen it. So I will give you some examples here of, so these are some screenshots of news articles over the past few years that created some controversy about our dependency on algorithms and the way we use data. So the first example is on Orbit, people discovered that Mac users were shown pricier hotels. Or there was this example of Amazon that when the company wanted to roll out its same-day delivery service, it inadvertently rolled it out in a biased manner. It excluded pockets of minority neighborhoods. And finally, the piece of software that I referred to earlier that judges are obligated to use in sentencing has been found to heavily discriminate against Black defendants. So software can make bad decisions, and I would like to claim here it can discriminate. And I would like to bring this a little closer to home a little bit, because perhaps you may not have observed this type of problems in those systems, but let's say something that a lot of us, I expect, use, Google Translate. So if you put on Google Translate, he's a nurse, she's a doctor, and you translate it to Turkish, which happens to be a gender-neutral language. So when you see the Turkish sentence, you don't know the gender of the person referenced. And then you translate back to English, this becomes she's a nurse, and he's a doctor. Perhaps unsurprisingly, but frustratingly, Google Translate also thinks that computer scientists should be male. So algorithms like this can exacerbate societal biases. I wanted to bring another example of the impact of this through a movie that I figured was popular in my generation, but while I was putting together the slides, I realized that this may actually be quite old for our audience. So I wanted to see if people know of this movie, if they have, you please respond if you have seen it, if you haven't seen it but know what it's about, or if you know nothing about it. This is a movie that came out in 2002, so I guess it's quite old now. It's a sci-fi movie, and it was quite popular back when it came out, and I see it referenced a lot now with respect to some of the ways algorithms are used today, which I will talk about now. But I wanted to get a sense of whether you're familiar with it or not. And I will describe, now that the poll has ended, I will describe a little bit what the movie is about. So Tom Cruise is heading a division. So I see, okay, most of you don't know anything about it. So here's what it is. So Tom Cruise is heading a division, a special crime division that predicts crime. So they go and arrest people before they actually commit a crime. And, without spoiling anything, because this happens early in the film, the system actually predicts that he's going to commit a crime, a murder. So he ends up being a fugitive, and I'm not going to go beyond that, but this is the main premise, crime prediction. And I guess what was science fiction back in 2002 is more of a reality now, when police are using computer algorithms to tell if someone is a threat. So in Chicago, for instance, when you get arrested, not when you get arrested, when you get stopped by the police see on their dashboard the score that is supposed to estimate how much of a threat you are. And that can lead to potential arrests. Similarly, in other cities like LA and New York, police are using software to do predictions in which areas they should patrol more. Interestingly enough, one of the developers of the system pointed out in this article that the system is not like Minority Report, but people see it as very much so. So we depend on algorithms to do this type of predictions in very critical components of our lives, but these types of algorithms do rely on statistics that propagate stereotypes and thus bring us into a vicious cycle. Now, aside from propagating societal biases, another problem with bias in algorithms is that they don't provide the same service to all. So I don't know if you've used YouTube captioning, automatic captioning before, but it's quite bad. And it turns out that it's way worse for female speakers than for male speakers. The error rate for female speakers is much higher. I also recommend for a similar topic to watch Joy Buolamwini's TED Talk on biases in vision software, where she demonstrates her struggles as a Black woman to use vision software, where it cannot narrow in on her face. The software can find her, but as soon as she wears just a fake white mask, the software instantly just zooms in on her. Okay, so I would like to leave you with some high-level directions that research in algorithmic bias is taking. So people have been wondering, looking into ways of how can we detect when bias occurs? How can we measure how much an algorithm is biased? If an algorithm is found to be biased, can we repair it by placing a repair on the algorithm? If the problem is on the data being biased and we learn about model, how can we repair the data? So this concludes the first topic, the research talk, and I'm ready to take questions.
Okay, so if you have a question, please just type it into the chat box and we'll relay it to Alexandra. I have a couple questions while we're waiting on some participants to add in some questions. So one question I have, this was so interesting because I just want to say I came back from a conference where the keynote speaker was Margaret Burnett from Oregon State, and she was talking about gender mag, M-A-G, and it is a process that she's developed to go through to decide whether your software is gender biased. So it was quite interesting that it's quite related to what you're doing. It was very clearly, it wasn't like an algorithm to go through. It was actually a process that people have to go through. They take on certain personas and they use the software with different personas to decide how's it going to react to those personas. So
interesting.
It's related to what you're doing here.
Yeah.
So one of my questions is how did you get into this? What kind of background did you have to get into this kind of research?
Yeah, so generally my research focuses on issues of data understanding. So I've worked, during my postdoc, I started working on bringing ideas from causality theory into databases. So my work then focused on, we have a query, just a structured query on traditional structured data. And then we get some result that we're surprised about, and we want to know more about this result. Is it because of an error? Is it because the result is really significant and this is possibly indicative of some discovery? So we want to know, we want to ask the question why. Why is this number high, or why is this particular tuple in my result? So then I was trying to figure out this relationship between input and output behavior in simple data systems. But this can expand, even though I was looking at it in the context of simple structured queries, this can expand in any system. How do we understand the relationship between a system's output and its input? And sometimes its system's output can be something that is behavioral. So how does the system perform for different users? Like we see captioning systems in female users and male users. So this theme of my research, trying to develop tools to better understand what data tells us and how data-driven systems work, is what sort of gave birth to this direction within my own research, trying to understand the more general behavior of systems that work with data. And this type of discrimination and bias is a type of system behavior. Sometimes discrimination is kind of a loaded term. For example, a loan application, it may be okay to discriminate on attributes like income, but it may not be okay to discriminate on gender, it's not our it's not in our tasks to decide what it is okay to discriminate on matters of policy, but it's about developing technologies to better understand system behavior when that system is based on data. It's driven by data.
Mm-hmm. So I was wondering how you designed data Xray. Were you looking for like bad patterns or idioms, or like how did you go about designing that?
So this is a good question. So data Xray is kind of a specialized system. We designed it to work specifically for knowledge extraction errors, but I would like to talk about some general applicability of it. But let me give you a gist of how the system works. So one of the driving factors was the system complexity in knowledge extraction. We don't really know. We can't really analyze the components of the system because they're just so very complex. So with that as our motivation, we decided to come up with descriptive summaries of the data, labeled data errors that demonstrate a similar pattern. And to do that, because the data set is so vast, we needed something that's parallelizable. And data Xray organizes data in a hierarchical fashion so that it sort of works from the top down in this hierarchy and tries to distribute these subtrees on different nodes and sort of can make local decisions of whether it should go deeper or not. Now, this is the gist at a very high level of the components of the system, but in terms of how the system works in the end, we discovered that even though our application was knowledge extraction, we didn't, because we didn't focus on the system specifics, like the extraction system specifics. We didn't try to reverse engineer and analyze the components of the extraction system. We decided to try to apply data Xray on different sorts of data. Data that is not necessarily generated by a data producing system. For example, we took weather and traffic data from the area of Portland, Oregon, and we this traffic data contain information on incidents like accidents on the road. So we treated an accident report as an error in the data, quote unquote error. And we tried to use data Xray to see if it could diagnose why accidents happen. Now we don't have a system to analyze, but the good thing is that data Xray was not trying to analyze the system. It was just working on the metadata, and that's how we could apply it. And so data Xray came up, basically tried to find patterns, meaningful patterns that group together these accidents, and it found things that are sort of intuitive, like it found groups of accidents that the common theme was a certain level of water on the road after rainfalls, and it found other sort of more complicated patterns, such as particular intersection a certain time of year, like around November, around 5 p.m. So we're not transportation engineers, and we don't know the specifics of that location, but our speculation is that this may indicate poor visibility conditions around dusk in a particular location a certain type of year. So by having a system like that works on metadata and doesn't try to reverse engineer the system that produced the data, we can actually use it to profile all sorts of data that is just from measurements. But if you think about it, even the data we measure, it sort of has an underlying data generative process that we're trying to understand. In this case, why do accidents happen?
That's interesting. It's really interesting that you can apply it in different places. That's great. Okay, I think we need to move on to the mentoring part of our webinar.
Mm-hmm. Okay, sure. So the mentoring topic that we're covering today is failures, and I try to be a little provocative and name it how to fail. But really, I don't want you to fail, but I want us to discuss why it is okay to fail, how to anticipate failing, and how to overcome it. And to start this talk, I wanted to do a poll because one of the main objectives for discussing this topic is I would like to demystify failures. I would like to normalize them, and I would like to show how this is something very prevalent that happens to all of us. So I listed a bunch of things here that I expect that some of you will have experienced. So, things like getting a low grade in an exam or an assignment or an entire course. If you've ever perhaps happened to drop out of a class, if your application to something like a university or an internship or a scholarship got rejected, if you did a job interview where you performed poorly, or really, any type of these types of occurrences in our lives that we consider failures or set us back a little bit. And I want to see if how many of these you have experienced at this point in your lives. And it looks like 30% of you say most of them, and 62% of you say at least some of them, and no one said none. So you can see already we all fail. But the thing is that our successes are very public and our failures are not. And that can be a problem sometimes because what we see in others are their successes. And what we see for ourselves is not only our successes, but also our failures. But when those failures are not visible on others, perhaps we let them reflect worse on ourselves. So when we look at someone's CV, and I put up some pages of mine for reference, things start looking impressive. All the places I went to for school, my employment, the awards and research grants and publications I got. But I don't publicize anything about the schools that rejected me, or the jobs that rejected me, or the awards I did not get, even if I got nominated for them, or research grants that I got rejected for, and God knows how many publication rejections I got. So what I want to point out with this is that the image that you see on other people is of their successes. This is what you're going to read on their CVs. This is what you're going to see on their web pages. And all of us don't list our failures, and that's what makes failures intimidating. That's why I would like to try to demystify this a little bit today. And I would like to do so by going over some of my personal experiences and some of the lessons learned from them. This part of the talk is really me narrating some things that happened to me during my academic career that I considered failures, or at least I considered failures at the time, and how those panned out and how they shaped my outlook moving on. So I would like to focus on a very common one, an exam failure. So, and I haven't had just one, but I will talk about the most significant one. And the most significant one happened when I was a graduate student. So as a graduate student, I had to pass a preliminary exam. So at Berkeley, then it was called the preliminary exam. This is called the qualifying exam in other schools. But the preliminary exam you have to take in your first couple of years, and this is the one that really you have to pass to really get into the PhD program. So even though I was admitted as a PhD student at Berkeley, I was not one quite yet until I passed that exam. The exam itself was quite nerve-wracking because it's an oral exam. in front of other professors who grill you on standard material and research questions and so on and so forth. So I'm listing it as a failure because I did fail the first time that I took it, and it felt very, very significant because it was a big step into me completing grad school. If I don't make through this, I will not succeed. So this hit me quite hard. What happened afterwards is I made several changes. I had to take it again the following semester, and in the meantime, I found a study partner to study together. I started auditing a class that I had already taken, but I felt like it would be useful for me to just sort of repeat the material. I also got in touch and set up meeting times with one of the professors that I hadn't interacted with as much at the time, who was in my area, in the area that I was working on at that point. And we set up frequent meetings to talk about research papers, research papers relevant to the class that he was teaching. I was setting up separate times with him to sit down and discuss some research questions and so on and so forth. I did end up passing my exam the second time, and it was the fact that I didn't pass it the first time now seems to me like a blessing in disguise, because I realized much later that the material that I really, really learned through my second experience, through the steps that I took with co-studying, reattending the class, having, sort of forcing research discussions with that professor, really made me an expert, not expert, but really made me, well-versed, knowledgeable in a lot of background material in my community, the data management community, that, I now, and in the past, I go to conferences and I meet with people who have done seminal work that I was reading about, and I know what they have done, what it is about. It helps me network much better than if I had just happened to pass the exam the first time. I really didn't have that background then. And I observe it now when I speak with some graduate students at conferences, and it's a striking difference I feel sometimes, not with everyone, but sometimes, I meet some students who just didn't have to go through the same sort of rigorous and step, or perhaps didn't meet that type of failure that forced them to study this way. And I feel really much better for having this background, gaining this background that I didn't have before. So I see that failure as a blessing in disguise, really. I also want to talk about a failure in my research, and I will not focus on just paper rejections, which happen all the time when we do the research, write the paper, we send it out to reviewers, they send it back with a reject. It's frustrating, heartbreaking, but happens all the time. But I want to talk about a major research failure, which is my dissertation. So when I was a graduate student, I worked on a very different topic than what I work now, and I feel that the research topic that I worked on was just not well suited for my strengths. My strengths were more on the theory and algorithmic side, and I was working back then on sensor networks, which was a platform that was rapidly evolving. So while I was there designing really smart algorithms to route queries and packages in a network in some smart way to save resources, the underlying infrastructure was quickly evolving under me, with sensors becoming much more powerful, their antennas being much broader, faster at communicating, not being so battery reliant, and all of that with the infrastructure changing under me made my algorithms, my ideas sort of obsolete too quickly. So that's why I felt at the time that, and even now, I guess, that my research on that topic didn't have as much impact as it could have potentially have had if I had applied my strengths and my expertise in a topic that was more suitable. At the same time, I'm not going to toss my dissertation out of the window. I'm still proud of the work that I did there, and I still consider the algorithms and the ideas I developed like really interesting and really smart. And the bottom line is that the core of the work that I did still keeps resurfacing in my current work, even though I'm focusing on very different topics right now. A lot of the techniques, a lot of the ideas, a lot of the strategies that I learned back then, along with the way to do research, still guide my current work, and the things that I achieve now are very much because of the work I learned and did back then. So even though I consider certain aspects of the work that I did for my PhD dissertation failure in some aspects, they still have great building blocks to support my future success in other things. Okay, another topic that I would like to discuss is failure to network. When I was a graduate student, I had a lot of trouble with that. I was a little shy in engaging outside of my comfort zone for reasons of, I didn't want to be perceived as, I don't know, I don't know enough. I'm not as confident as the other students. Also, I was a new immigrant at the time. I moved to the United States for graduate school. So it was hard being in a new community, and I got myself to socialize with people from my home country more than anyone else, rather than working on to develop more professional connections. So I failed to hang out enough with my lab mates, my fellow computer science students. Even at the time, I failed to participate at the Women in Computer Science event. I didn't realize at the time how important these opportunities to network were. And, these will always be missed opportunities, but, looking back and realizing the impact that this had really makes me now more open and more adept to seeking collaborators and mentors, and also to not hesitate to ask for help and sharing concerns when I need to. Communicating our needs is really important in getting them met, and whenever we're struggling with something, actually telling it to someone who can provide assistance is the first step in resolving the problem. Okay, so I already talked about how I felt that my dissertation had some failures, at least. So as an effect, the job search that I did at the time when I finished graduate school was not successful. I even tried, various things. I was not looking for academic positions at the time. I did send out a few applications just, in case. But, I interviewed at some hedge funds and things like that. And I was just not suited for those jobs. And it was a spectacular failure. And I'm just so glad about this now, because what happened after that failure was that I found a postdoc position, at the University of Washington, and so I stayed in research, and it allowed me the opportunity to switch topics, play more on my strengths, realize my love for academia and how I feel better suited in this type of work. So even though I failed to find a job then, that slowdown was temporary, and it allowed me to pursue much better opportunities later on, opportunities that suit me better than those that I tried to get at the time. So I would like to conclude with some good practices after all these anecdotes from my life for handling failures and possibly avoiding them. So one is to not isolate yourself first in the face of failures. Often when a failure happens, we are ashamed of it, we're hesitant to share, or even before the failure happens, when we're struggling with something, we don't seek help. We need to seek mentors effectively, even aside from failures, before failures happen. Even if failures happen, it's not the end of the world. They happen to everyone. And we need to think about how to make use of them. What can we learn from them? I learned a lot from many of my failures. One thing is how to avoid failures in the future. And another thing is how can I take building blocks from my failed attempts in order to reuse them and succeed in something else. More importantly, don't let failures reflect on your abilities and prospects. I know it is easy to say and hard to do, but the thing to remember is that we all fail. You're not alone in this. We just need to confront the reasons for failure and try to correct them in the future and learn from them. And the bottom line is that when you look at other people, you mostly see their successes. You don't see their failures, but their failures are there. These people that you look up to, your role models, are successful because they've gone through failure, they learned from it, and they overcame it. So it doesn't happen to just you. That's the thing to remember. This is how I'm going to conclude, and I'm open to questions.
A lot of that, the failing at different points and then learning from those failures is huge. And I think people who are in research careers face it a lot. I think we're always putting ourselves out there with papers that we write and presentations that we make and proposals that we write. And we know when we put them out there that the acceptance rates are 10 to 30% or whatever. We know that when we do that, but we continue to do it. And I think that every time you get a rejected paper, you still feel bad for a day, but you learn so much from that experience, and the paper always gets better when it goes back out.
It's true. I learned a lot on this from my postdoc advisor, Dan Sutu. He was, every time back then, if we got a rejection as a postdoc, I was like, why did this happen? These reviewers, they didn't understand anything. and Dan would be like, oh, no. If the reviewers didn't understand it, it's our fault. We didn't write it correctly.
Exactly.
He was so zen about it, and you're right. These iterations make the papers better. And look, there's always some amount of randomness and luck, a little bit in everything. But yeah, we do improve from our failures, and we get better.
Definitely. And I think a research career has a lot more of that than some other careers.
Mm-hmm.
That face it more often, I believe, in our careers. And so it's good to not think of it so much as a failure in some cases, as okay, it wasn't good enough this time. I need to make this better.
Mm-hmm.
Yeah. So I really appreciate that. Was an excellent talk for many, many people who are researchers at any level, actually. I can still remember the first time I served on a panel for a conference, and I was amazed at papers that were getting rejected, and the authors that were on those papers were people I just so respected, and were like, oh my gosh, their paper just got rejected. Okay, I'm feeling better now. It was kind of eye-opening to know, yes, indeed, because we don't see that, right, on the resumes.
Of course, yes, the failures are hidden, yes.
But it does happen. It happens to all of us.
Yes.
So that's great. Well, this was wonderful. We're running out of time, so what we're going to do is we have 2 more slides to tell you what happens next in terms of surveys. We really want you to fill out this feedback survey. We're using this survey to give us suggestions for other talks, other areas of interest to hear on these webinars, ways we can improve the webinar experience for all. So we really appreciate if you fill out this survey. And I believe the last slide is mostly about CRA-W. If CRA-W is an organization of the Computing Research Association that has a lot of other kinds of programs beyond this undergrad town hall. So there's lots of mentoring workshops with travel funding to go to those workshops and there are different places on the pipeline. So there's a lot of different resources that CRA-W has. So we suggest you go to the CRA-W site if you want to see what other kinds of programs we have. At this point, what we're going to do is we're going to go into an online chat, and you need to use the chat box and send to all attendees, and we will all see the questions, and Alexandra and I will answer questions. So it's basically going on to an online format. And at this point, I want to really thank Alexandra for her time and all that she's put into wonderful both research and mentoring video. This was wonderful. This will be online recorded on the CRA-W site. If you know of some friends that you think should come and listen to this that missed it today, it will be available online afterwards also. So thank you very much, Alexandra.
And thanks for the opportunity. I really enjoyed this.
Yeah, it was great. So we're going to move on to the online chat at this point. Mm-hmm. I'm hoping you all sent questions in.
So I see a question here. Do you find that your colleagues are willing to talk about their failures openly? How can we normalize this more within academia? So I do find that, people don't tend to publicize their failures. We're all proud, right? But I think when you are in a community, you do connect with people a little more closely. This is why I suggest to seek out mentors. And these mentors, these people with whom you will connect more closely, will share more with you. Maybe you're not going to find all the failures that everyone has faced, but I think people have been quite open with several significant ones. There's also has been an effort. There has also been an effort with that I've seen online with people publishing like CVs of failure, like their failed attempts to stuff. So I think that's also an interesting attempt. But generally, people are open.
Hi, everyone. This is Earl. All the attendees have gone. I only have my 2 recorders left, so if you want to chat or anything, we can do that.
Hey, Lori.
Hello?
Hey.
Hi.
I didn't see anything that went out or came in from all attendees, only things that said they went to all panelists.
Same.
Okay, I'm going to take the presenter's ball. I want to see what you guys are seeing. So what I'm going to do is share my screen here. Hold on.
So I sent something to all attendees that was a question for Alexandra, but I don't think she ever saw it.
I didn't see it until you sent it again to panelists.
Yeah.
So I didn't get that one, but I got some other questions that were sent. Oh, you had sent it to all attendees. Right, so questions to panelists I got.
Yeah, I didn't get anything that said it came from all attendees. Everything I got says it came from all panelists.
Same. Or was sent to all panelists.
Yeah. I
So,
definitely sent the first one to all attendees so they could see my question, hoping it would prompt them with a question. But then Alexandra wasn't answering it, so then I thought, okay, maybe I need to send it to panelists so she sees it.
So I think I replied to all attendees. I'm not sure that it went through. I have several replies. I was sending it to all attendees.
And I am seeing that, and you guys will get the chat out of this. My concern is that you guys weren't able to see it.
I don't think we were seeing any of that. I mean, I see that you have a recording that says she sent it to all attendees, but we weren't seeing those.
Yeah, that's what
I don't have any of that on my record of my chat, which is like a big problem because how are they supposed to answer real time when they can't even see the question?
Right. Or we're not seeing the question.
Right, we're not seeing it. It was there. Like I said, the recorders have it. The one question that I have maybe is that when the chats went out, if they had the polling panel still up, they would not have seen the questions come in.
Right, but like I don't have the polling panel up and I still can't see it.
Right. I had just the chat and I saw one person's that they sent to all panelists, and that's the one Alexandra answered. And then I sent one to all attendees, and she didn't answer, so I sent it to all panelists and said, did you see this question?
Yeah, I had not seen that one, but I got, right. Oh, also that's interesting. Maybe I see only my own that I sent to all attendees, and I don't see anyone else's.
Exactly. I saw my own.
Okay.
I couldn't see anybody else's.
Okay.
Exactly.
I see. So if people were sending questions to all attendees, we wouldn't be getting them.
If they would have sent them to all panelists, we would have all seen them. What I think they did was they sent probably to specific people instead of just sending it as all panelists.
So, but aren't panelists attendees as well? So for example, when I reply to all attendees, shouldn't Lori and Daniela also see it?
Yeah.
It doesn't, and I don't know why it doesn't work that way. As the host, when I send out chat to attendees to let them know how to ask questions and things like that, it doesn't show up for the other panelists.
Oh, I see. But okay, so you think that the attendees actually saw my answers? It's just that the panelists did not see my answers.
Yes, as I said, the recorder's there. You can.
That's never happened before.
Yeah, that's what I'm taking notes down. I won't be able to do it today, but first thing in the morning when I get in, I will call IT and find out if this is something new, or I will make sure that I have a ticket for this particular issue about not seeing the messages that were sent to all attendees.
Okay.
I don't know if we saw the ones coming in because I only saw one that came in to all panelists. So, were there any others that went to all attendees that didn't come from us? 'Cause I didn't
Not
see-
that I saw.
Oh, okay. Okay. Other than that, it was a great session, Alexandra.
Well, thank you. We didn't get questions from the attendees though on the in the research.
Right.
That happens, though.
It happens. Yeah, we do have that happen.
Okay. So you don't think it was just not accessible?
No, I thought it was
great.
great.
It was a great webinar, Alexandra.
Yeah, you did an amazing
Look,
job.
I don't know anything about computer science, and I thought it was great, so I'm sure everybody could understand more than me.
Okay, thank you.
They don't usually ask many questions, and we often are the ones setting up the questions.
Prompting the questions. It was just difficult because we were trying to figure out what was happening.
Yeah, sometimes once we ask a few, they'll start asking them.
Mm.
But they couldn't see apparently anything that we were doing, so.
Right.
It's kind of hard to get them to prompt them to act when no one can see what's happening.
Yeah.
By the way,
maybe we'll hear something from the evaluations.
Yeah, we might hear something there.
okay. So by the way, the polling thing that, I was connected to the other computer to see the polling. Apparently I didn't need to do that because a polling panel was popping up in front of my presentation. Yeah, so it was there.
Oh, that's
Yeah, to know for the future.
Yeah, that's great. Yeah, your talk was excellent. It was right at the right level, and your mentoring the failure topic is a great topic for this audience.
Yeah, it's important. I think freshmen fail a lot, and undergrads fail a lot, and it's probably their first time failing, so.
Yeah.
Yeah, it's harder in the beginning. Now we get paper rejections, and it's like,
Right, we just get okay. So much
You're
for
kind
that.
of primed for it now.
Yeah. Unfortunately.
Oh.
Yeah. Well, okay. Well, thank you very much.
Thank you, Alexandra. Lori, do you how do you want to handle the next set of booths? Do you have people in mind?
Sheila and I will have to talk. I mean, we have the next one for this fall.
Yeah, we have Anna presenting in November.
Right, and then
Which
Sheila.
I can reach out to her and get all her information. I've been working closely with her on the sexual harassment resources page.
Okay.
So she and I have established a sort of rapport, so I can reach out and get everything.
Great. Okay.
Okay.
Yeah, Sheila and I will get together and discuss. We'll set up a call and discuss who should we invite next. We'll come up with a set of lists. Yeah.
Awesome.
Great.
All right.
Thanks a lot.
Well, thanks again, Alexandra.
Oh, thank you all for setting this up.
Yeah.
Have a nice evening.
You too.
You too.
Bye.
Bye.
Bye.